In this example, we're going to find the formula for the piecewise-defined function g whose graph is given. One thing to note is that finding the formula, this can also be stated as the definition of the piecewise-defined function. To do this, as we look at this graph, we can see that there are three key pieces here. The first one that we see, it's a slanted line, and we can identify that piece as a linear function. The second one, we see a flat horizontal line. We'll know that that piece will be defined by a constant function. And the third one on the right, again, slanted straight line, we can identify that as being linear. So when we break each of these pieces down, let's look at piece 1 first. And we noted that that's linear. So what we're going to look for, linear function is defined by y equals mx plus b. The slope, m, we can read that off the graph. So I can see that for this piece, the slope's going to be 1/2. Now, as far as finding the value of b, there's a couple ways to approach this. The first is to look at this piece and to look on the graph where this function would pass if it were graphed for all real numbers. Now this will work great as long as that y-intercept is an integer value. In this case it is, so we can see that it would pass through 0, -2. So we can tell then that that value of b should be -2. Now this won't be the case for all piecewise functions. If that happened to be -2 1/3, we wouldn't necessarily be able to read that off the graph. So another way we can do that is to take a point, and I can see the point -2, -3 pretty clearly here. And so I'll take that point and solve for the value of b. So what that looks like then is I plug in -3 for y, plug in 1/2 for m, plug in -2 for x, and now I'm going to solve for b. So that will have -3 then equal to -1 plus b, and that makes b equal to -2. So this formula will be defined by y equals 1/2 x minus 2. The second piece, this one's a lot easier. Since this is constant, it's just going to be defined by y equals some number c. That's the general formula. Now, that number we can see on this graph should be 5. So here, we're going to have y equals 5. For our third piece, this one we noted was linear again. And so we're looking again to read the slope off of the graph and then to find that value of b. So if we come over here, we can see that this slope should be, go up to left one, that makes the slope -2. And again, we could either solve for the value of b, or we could read it off of this graph. And so for this one, I can see that b is going to equal 7. I could calculate that in a manner that I did for piece 1 if I wanted to. All right, so that makes this formula y equals -2x plus 7. Now the last step here is to write the formula for the entire function. We have each of the pieces defined, but this is a single function. So we're going to have g of x, and that will equal, and we're going to have 3 cases here. The first one, now we have g of x out front, so all we're really writing is the outputs here. We have g of x equals, and then we need the output. So that first output is 1/2 x minus 2. Now, to figure out what values of x this is defined for, we'll again go back to our graph. And as we can see here, this first piece, we can see that it goes from -2 and goes left, and at -2, -3, that circle's filled in. So that means that this piece is defined for all values of x less than or equal to -2. The output of that second piece was just 5. And coming up to the graph, we can see that it goes from -2 to 3. At -2, there's an open circle. At 3, there's a filled in circle. So that means that we're going to go from, this will be -2, strictly less than x, less than or equal to 3. And for that third piece, we had -2x plus 7. And we can see here on this piece that there are open circles on each end at 3, 1, and again at 7, -7. So this will go from values of x where 3 is less than x, which is strictly less than 7.